Alright, hey guys, so I'm gonna make a video on this because I feel like it's a lot easier for me to do. So we're gonna do R and S configurations today. So basically, the best way to do this is to figure out, okay, so we know we're doing R and S configurations for chiral carbon centers. And so what this means is 4 different substituents or groups attached. And so basically what this means is, say we have a carbon with a methyl group, a hydrogen like this, a ethyl group, and then we have, say, a OH group. So this is what a typical chiral carbon will look like. And so kind of how we figure out the configuration to be RS. So R is going to be always clockwise of priority groups, and S will always be counterclockwise. And so how we determine this is kind of, these are the steps we figure out to rank the priority groups in order to determine if it's R or S. This is how it's going to help us determine the numbering in order to determine that. So first off, we look for, based off of all of these groups, we want to determine what's the lowest priority, meaning what has the least atomic number, least atomic weight. So we'll look at atomic number and weight. So as we can see here, hydrogen is going to have the least out of the 4 groups. So we're going to number it, let's say 4, and circle it. And we're going to get circles for trying to number all of these to determine what they mean. So second off, let's look at our next group based off of priority. So let's see. So when we look at these 2 groups to determine the priority, we look at which one has more atomic weight, a longer chain, and okay, so now we can see here, in order to compare methyl and ethyl, we can see that ethyl has another carbon and more hydrogens attached, so automatically that's going to be higher priority than the methyl group because it's longer and has more atomic weight when you calculate the atomic mass. So we're going to put this as 3, so right next to hydrogen being the least, and then it's going to be 2, and then process of elimination is going to make this 1. And so basically, when we're doing this, we want to make sure that we're determining, okay, so in this numbers, when we see these numbers in the circle, which one is going to be our least priority, most priority, and then we count up. So we see 1, 2, 3, 4. And so what we always do, and what I've seen online, is like you always cross out the least priority so you can determine how it goes. So because you don't need to worry about it, it's already the least priority group, it doesn't really matter, and it's invisible anyways when we look at a molecule. So we see it goes this way. And another point to show is that, say we have a dash here with this OH group and a wedge and then a dash here. If hydrogen is a wedge, if hydrogen is a dash on the molecule we're given, if it's showing a dash, then we always count in the direction that it's going originally. However, say we get this molecule. Say it's like this. CH3. Let's do OH. And it's like this. And then it's CH3, CH2. So I don't know if you can see this, but see if it's like that. And so then if we see this here, we know we have to switch this to a dash, which will say, so let's list this priority real quick. Let's list these groups into priority. So this will be 4, 3, 2, 1. And so when we ignore the hydrogen still, we're gonna get R. However, since this hydrogen was dashed, and we always want the hydrogen facing the back, which is, since this is a wedge, and we want it to be a dash like this. And since a wedge means it's pointing towards us, we always want the hydrogen to point behind us, so always on a dash like this. So in order to do that, we have to flip the configuration to go S. So the reason why this is S is because originally this hydrogen was on a wedge, which we can't have. And so basically when we're looking at these two molecules, it'll show us, we look at the priority, we number the priority based off of atomic weight, mass, length, and making sure that we can identify which one has the most weight, which one has the longest chain in order to determine everything. But always when we see molecules like this, the invisible hydrogens will always be the least priority force. You can automatically cross it off, and then we can do the counterclockwise and clockwise rotation. So since this molecule, hydrogen was already on a dash, we don't need to flip it, so we can just do the original 1, 2, 3, which is R. So this will be our configuration. For this one, since we had to flip it, since this was on a dash, or wedge, we had to flip. Instead of going this way, we had to go this way, and we got S, because S is counterclockwise. So I hope this helps, but also too, when like you're looking at a molecule, it's easier to determine the priority groups and the substituents by circling each chiral carbon to be able to see, okay, what's to the left and the right, and then what would be invisible. And the hydrogens are normally always invisible if you're looking at a line structure. But a lot of times for like condensed formulas, when it draws out like the name and like the molecule and each atom in it, it'll kind of help you determine